Recently in class, we have been discussing quantities and variables. Unfortunately, often in math and science class, teachers ask students to solve problems without first having a clear understanding of the quantities involved in the problem. This can make it extremely hard for us to make sense of what is happening in math class. It can make it very difficult for us to see how we can use what we are learning in class for anything useful. In this course, we want to take a different approach. Throughout our pre-calculus lessons, we will make it a priority to define quantities and variables so that we can reason together and make sense of our mathematical activity. Recall in our previous work that we have defined a variable as a letter that is designated to represent all possible values that a varying quantity can assume. And we have defined a quantity as a measurable attribute of some object. So, defining a variable requires that we clearly identify some quantity. And to define a quantity properly, we must be sure to mention the object that is being measured, the attribute of the object that is being measured, and the units used in the measurement. With this in mind, let's say that we are studying a situation where Sean is walking from his car to school and he passes a tree along the way. In this situation, saying let t equals time or let d equals distance makes little sense. Let t equals time, what does that mean? Time since when? Let d equal distance, what does that mean? Distance from where to where? We can do a much better job defining variables for this problem. If we say, let t equal the amount of time measured in seconds since Sean started walking away from his car, and let d equal the distance measured in feet that Sean is away from the tree, then we can think and reason about the situation now that t and d are clearly defined variables. We can also define constant quantities that do not vary or change in this situation that we might want to use to answer questions, such as the height of the car measured in feet. That's a clearly defined quantity that's not a variable because it's not a changing quantity. Also, another constant quantity could be the width of the school building measured in meters. With this short review in mind, provide clear and complete answers to Module 2 Investigation 1, question number 5. You will need to imagine Monica running around a track to answer these questions, and it will be helpful for you to draw your own picture of the situation and reason with it as you imagine Monica running and as you reason to answers for all parts of question 5. Question 6 asks you to use an algebraic expression to describe one varying quantity in terms of another varying quantity. This means that we will be describing one variable using an algebraic expression that contains the second in terms of variable. For example, in part C, the problem tells us that x stands for the varying number of feet that Jo is away from her front door. We also know that the distance between the door and the car is 40 feet. We are asked to express Jo's distance from her car in terms of x. That means that we will write an algebraic expression that contains one or more x's in it that will describe Jo's distance from her car. To come up with an answer for this, let's consider a picture of the situation. When we draw a picture that shows how the fixed and varying quantities are related to one another in this situation, we see that as Jo walks to her car, her distance from her door, this varying quantity represented by the x variable, that is changing. It is increasing. And Jo's distance to her car, another varying quantity, is also changing as Jo moves. It's decreasing. However, we can see that both of these two distances must add up to 40 feet, a fixed quantity in this situation. So this diagram allows us to see that if we take the 40 feet and subtract off x feet, Then we will have a representation for Joe's distance to her car. If we subtract this distance off, then what is left here will represent Joe's distance to her car. And the way we were reasoning through that is we took the 40 feet and we subtracted off the distance that Joe was to the door, which is x. So now it's your turn. Answer all parts of question 6 by thinking carefully about all of the quantities in the problems, drawing a picture of the situation, and making sense of an algebraic expression that will provide an answer to the question. Submit your answers to all parts of questions 5 and 6 in Module 2 Investigation 1 using your instructor's preferred method by the time and the date that your instructor has identified.